Here's a brief video, I'm going to try to keep it really short, to discuss division rules for exponents. There are only 2 division rules for exponents. Remember, for multiplication there were 3. Okay, so we've got rule 1, and down here we've got rule 2 with examples. All right, remember for multiplication, our first rule was the addition rule, okay? So remember that multiplication and division are opposites, so we're expecting our rules to be a little bit opposite. Okay, rule 1, for example, we've got 3 to the 8th power divided by 3 to the 3rd power. Now you can type this into your calculator and get a ridiculously long answer and divide and come up with a number answer, but that's not what we want to do. We want to practice using our exponent rules because we're going to replace numbers with variables soon. Okay, so here we are. 3 to the 8th power means 3 times 3, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 3 to the 3rd power means 3, 3, 3. 1, 2, 3. 3 times itself 3 times. Now, when we divide, 3 divided by 3 equals what? 1. 3 divided by 3 equals what? 1. 3 divided by 3, 1. So what's happening to our powers? When we divide a number by itself, it cancels. So how many powers of 3 remain? 1, 2, 3, 4, 5. Okay, now what could we have done with this 8 and this 3 to get us 5? We could have subtracted them. Does that make sense? So this is our answer. But look at this. Let's see if that happens again in this next example. So we've got 5 squared, 5 times 5. X to the 5th power, let's expand it out. 5 powers of x. On the bottom, I've got 1 power of 5, and then 2 powers of x. I'm not going to write it here. I'm going to make sure I stack my x's so that I can cross them out. Okay, so now let's cancel what we can. 5 divided by 5, 1, gone. X divided by x, 1, gone, gone. So now just collect what remains. I don't have anything in my denominator, so my answer is going to be a whole number. So let's collect it. I've got 5 times x times x times x at the top, which is basically 5 times x to the 3rd power. Now, let's look what we had originally. We had 5 squared over 5 to the 1st power. Remember, our power of 1 is invisible. So 2 take away 1. What do we do with our x exponents? Okay, 5 take away 2 gives us 3. So we're going to call this rule the, you guessed it, subtraction rule. Okay, because if I just subtract my powers, then I don't have to do all this expanding and canceling. If you like to expand and cancel, be my guest, okay? So here is the official subtraction rule, and this is how it's going to look on your star formula chart. So you do want to kind of make sure you take a look at that. All right, so once again, if I have same base with an exponent divided by same base with an exponent, I keep my same base and I subtract my exponents. That's what that means. Okay, let's move on to rule number 2. This one has parentheses again and an exponent on the outside. And I am dividing my bases. 2 different bases that I'm dividing. Okay, so what are we going to do here? It's going to be pretty much like the last sharing is caring rule. It's just sharing is caring for division. Okay, so everybody gets a 3. So basically, we'll end up with what I really needed you to do is know that right here, everybody gets a 3. It's basically 3 halves times 3 half times 3 half times 3 half, but I didn't leave you enough room to do that, okay? So basically I have 3 to the 4th power over 2 to the 4th power. And that is our sharing is caring for division. Now, I'm not gonna make you expand it out like that every single time, but just so you know where the rule comes from. One more time, x over y to the third power means x over y 3 times. Which means x to the power of what? Over y to the power of what? Okay? Now these next ones get a little bit messier. A little bit messier. So let's do it. So right here I have 4x over 5y times itself times 4x over 5y. And you can see already, how many 4s am I going to be multiplying together? 2. How many x's am I going to be multiplying together? 2. How many 5s? And how many y's will I multiply? In other words, every single base inside the set of parentheses, whether it's on the top in the numerator or on the bottom in the denominator, every single base gets a 2. You get a 2, you get a 2, you get a 2. Everybody gets a 2. And that's what we end up with. Now we're just going to clean it up. What is 4 squared? It's 16. I can't clean up the x squared, so just copy it. What is 5 squared? It's 25. I can't clean up the y squared, so just copy it. And that's my answer. I do, of course, want to make sure that 16 over 25 does not reduce. So you already know you're just going to try to reduce that either by hand or in your calculator. However, 16 over 25 does not reduce, so that is our final answer. One last example, and we'll be done with division rules for exponents. Once again, as I said, everybody is going to get this exponent outside. The 2 gets it. The x squared gets it. The 3 gets it. The y to the third power gets it. Everybody gets a 4. This is not going to be enough room for me to work, so let's do it over here. 2 to the 4th. X squared to the 4th. Remember, we need those parentheses so it doesn't look like 24, okay? The parentheses separate the 2 from the 4. All right, and then on the bottom, 3 gets a 4th power. And then y to the third gets a 4th power. Remember, parentheses to separate those powers from each other. Now we got to clean this up a little bit more. From yesterday, or not yesterday, but from our multiplication rule video, we learned what happens with these. When I can circle 2 exponents that are riding piggyback on one base, and here, what do I do with those exponents? I multiply. So, oh no, we're bringing back the multiplication rules for exponents. And you're going to notice you kind of have to you have to combine whatever you can. You're going to use these rules all together. All the rules in your tool belt, you have to use them. So let's do that. 2 times 4 is 8. And 3 times 4 is 12. Now we're almost done. You're just going to clean up these numbers and get that done. 2 times 2, 4 times another 2, 8 times another 2, 16. 3 times 3, 9, times 3, 27, times 3, 81. Of course, you can do that on your calculator, and that'll be your final answer. Okay, so one last time, this is how the official rule looks. Oh, I just wrote over it. Okay, this is how the official rule looks. That says M. And this is what it's going to look like on your star formula chart. So you want to recognize it. Oh, there's a typo here. There should be an M on the outside. Okay, so it says basically, when I have 2 separate bases, or 2 whatever bases, and an exponent on the outside of those parentheses, 2 bases being divided, what do? I share. Everybody gets an M. Okay, that is the official rule that will be on your star formula chart. Good luck with your exponent rules. And there we go.